So we need to talk. Does anybody know what this picture is telling you? My mission here is to kind of shock you guys out of some old, I wouldn't call them bad habits, but they are partly obsolete. At the same time, I want to shock you out of your old habits. I want to inspire you in two directions in the future. One is what I've been calling Agile AI, but others at this conference have called operationalized AI or productionized AI, or our friend from Adobe yesterday called it AI at scale. This is so new, we don't even have a name for it, right? We're all in this space where there is no clear name. And just to give you a preview, we're really talking about the software engineering for AI. But wait, there's more. Once we solve this problem, we are on the precipice of a solutions renaissance. AI has the capacity to solve way more than building the next cool app or the next cool marketing or advertising application. I'm here to share with you some good news from Silicon Valley, where my company is based. There is a groundswell of people who are interested in both cultural change as well as technical change. Why aren't the most advanced technologies and some of the most innovative people on the world solving the hardest problems that we face? Income inequality, poverty, climate. Turns out those problems are amenable to this next generation of AI, and those problems aren't separate. They're all the same problem, and we'll talk about that. So this is a picture you've seen in one form or other over the last 24 hours. We've been focusing on models, okay? How many people attended a talk about some algorithm or some model today? Good. The vast majority of you were in that space. We have been systematically ignoring good practices about data. Okay, now there are certainly great data governance technologies out there, but there's some AI-specific data best practices that aren't well understood. We've also been systematically ignoring what happens when you insert that AI brain into a production system or into an application, and the unique challenges that arise that go beyond traditional software engineering. And then as you deploy that out into the world and pay attention to your users and the market. And we're starting to see some of the unintended negative consequences of ignoring these downstream links in the form of AI bias and issues with AI ethics. So we need to build the airplane, okay? You guys are great jet engine people, and the field as a whole has been focusing on the engine. But what does it take to build the airplane as a whole? Pushing my analogy a little bit, we can think of the airplane as all of these pieces. It has that jet engine, which is that very innovative part that makes it go, very important, but it has a number of other pieces. And so what we've got in terms of the history of AI is the situation where we have a mountain of data. What is it now? Exabytes, petabytes, huge amounts of data get generated every day. Next to that, there's a mountain of AI research. I've been in it for 30 years, but this field has gone on for half a century. And what's happened over that half century is 99%, that's my not very well-grounded empirical number that I get from my experience, 99% of that work has been in academics. It is like we have had 50 years of people building jet engines, but very few airplanes, okay? And the airplanes that we're starting to build, some of them work pretty well. Some of them are specialist airplane building companies, but we lack a discipline of how we get from the engine to the larger picture. And it turns out that discipline doesn't just involve building frameworks and building the airplane. We also, if we look to engineering, how do we go about building a skyscraper or a car? There's a design methodology, okay? And there's an engineering methodology. And we, as humans, the way we build complex artifacts is we do good design, we do good planning, we do construction, which we're all pretty good at, and then we have assurance. And that kind of sounds boring, right? If you're into the sexy algorithms, why would you want to do assurance? Well, it's not boring when it gets you a job. It's not boring when, as a C-level executive, it means your project is 7 times more likely to succeed than it would otherwise be. Okay? It's not boring when it allows you to enter AI, if you're new to this field, in complete white space that has yet to be covered. That's pretty cool. So today I'm going to talk about this picture. And if you look at these 4 disciplines and then the 4 things that you might build, and I'm not saying this is necessarily a framework that everybody agrees to, but it's something like this, right? We have a 4x4 matrix. There's 16 different disciplines that you can sit within. Now, the vast majority of us have been sitting in model construction, okay? But you can be in AI data assurance, assurance for users. So pick a box, whatever you like. Okay, this is the future of AI, and the good news is we've been through this before. This is what happens when we go from a science technology, when we learn how to build a television, to when we become, a television CRT, to when we become Sony, right? It is the discipline of taking something that's very innovative and inserting it into something that's marketable and useful and has value. And what's cool about AI is the value that it has the potential to solve some of our largest, most complex, interdependent problems that we face. So I'm really going to talk about two futures today. One is the future of applied AI, if you guys are a little bit more tactical. But if you want to be visionary, I'm also talking about the future of this larger picture called decision intelligence. Good questions. We'll get a copy of the book. And decision intelligence goes way beyond AI to incorporate a lot of different technologies and disciplines, including scientific disciplines from the social and behavioral sciences, economics, in order to solve these very hard problems. And it's really cool. So I invite you to take a look at the book. If you don't get one, I've also got brochures to get a discount. All right, so let's dive into it. Today, I don't have time to fill in all of the boxes. I picked the ones for you that I consider the top 10 important lessons from this picture that A, most people epically fail at, and I have epically failed at this. So I'm no better than anyone, except I've just been doing this for 30 years, and I've been through the freaking ringer with it. And so I'd like my failures, as well as my epic successes, to be yours as well. So I'll share those with you. The other ones are the ones that make a big difference, so the ones that are likely to fail, the ones that have a big impact, and then I picked a couple that I think are pretty cool. Now, Barney Pell and I are writing this book. This is a mock-up. This is not a real picture of a real book. It's about chapter 3. It'll be out next year. So if you follow him, and I'll have his Twitter handle, you'll read about him. Barney is pretty exciting. We hadn't talked for 30 years since we ran the NIPS conference together. We were on the program committee there, now called NURIPS, if you know that show. And we get together, and we have coffee, and we start talking about what we think is missing. And we end up finishing each other's sentences. And I think anybody, and I've talked to a few of you here at this conference, anybody who's been around the block a few times recognizes there's this giant desert of engineering best practices associated with AI. And so today is your introduction to that desert, which is all of those other 15 boxes, except for the one with the engine in it, which is where you guys have been living all along. Okay, is this boring? No. This is pretty cool because if you're not already a data scientist, this is a way to get into it. If you are a data scientist, this is how you separate yourself from the pack, and it has this really great potential. So this is the eye chart. I'm not expecting anybody to read this, but this is why I suspect I'm right. I'm the inventor of something called machine learning transfer learning. We heard about BERT yesterday. If you go on Wikipedia, you'll see that I invented that, which is really cool. So I think maybe I've got good intuition for these sorts of things. I've also built thousands and thousands of models for computer vision and weblog analysis and retail. I built a $100 million budget for the US federal government. I've done a lot of disease treatment. We do a lot of work in telecom, hazardous waste. And one of my favorites was visual hair analysis during the OJ trials a couple of decades back using neural nets. Backpropagation, right? Which is really what we're still doing, just a little bit deeper backprop. So what I'm doing is I'm taking what I've seen systematically as I failed regularly, and as I saw my clients fail regularly, I noticed some systematic patterns. And so I'm going to share those with you today. Now, you would think, and this is where most people go, that traditional software engineering best practices bolt them onto an AI engine and away you go, which is sort of right, but sort of wrong. And some of the epic fails that I've experienced have come from not understanding that AI projects have some fundamentally different characteristics. In particular, think of your AI app or your AI system. In the core of it, it's going to have this model, this brain. What is that model? It's meant to be a reflection of the world, right? And the world is always changing, okay? So most applications, there's a few exceptions to this, but most applications, if they have good performance in October, their performance will drift, and they'll perform real crap by the following October or the following year, unless you keep things up to date. So we're really dealing with a moving system. I mean, Microsoft Word, if they never updated it, it would still be a useful tool, right? Excel, great tool. If they don't change it, I would keep using it. Anything that has a model in the middle of it, that model is a bit of a simulation of the world. The world is changing, which means the data is changing, which means your model has to change, which means your app has to change, which means your market product fit is constantly in flux. And as you're building a product, you need to be aware of these hinge points. And as you're a project manager for these things, or a software engineer, if you're not aware of these hinge points and the disruptive nature that they have within any AI project, you are more likely to fail. And we're seeing a number of reports come out that says only 1 in 10 AI projects are successful. I hope that's not true. If it is true, though, here today are some of the keys for that not to be your team, for you to be that 1 in 10 that makes it. So this is more like an R&D project, okay? This is more like experiment and then produce, and then experiment and then produce. And because of that, Agile techniques become more and more important. Now, I'm not going to teach you about Agile today. I'm assuming you guys can look that up. When I say Agile AI, what I'm really saying is let's skip the 2 decades of waterfall methods. We learned that lesson in traditional software. Let's go straight to Agile. And there's a lot of details that have yet to be worked out as to how we apply Agile. But the specific aspect of this is that we need to work in short, tight iterations that are focused on reducing risks at each one. That is common. And so from that point of view, a lot of the Agile techniques apply to AI projects, but in new ways. So this is the situation I see on a lot of projects. So I work with clients worldwide, and one of the ways that I do that is I'll come in an advisory capacity. And I will sit down, and they'll bring in their data guy, and their data guy will tell me about all of their tables and their data governance technique and how they've cleansed every single one of their columns and joined their data and have a master data management system or something federated. And he'll be very proud of that. And I have to gently tell him chances are he's wasted a lot of time. And I'll talk about that in a minute. Then the modeling guys will come, and they'll tell me about their algorithms, and they'll go inside the box, and they'll do the theorem proof that their algorithm achieves a maximum likelihood model. And honestly, I've heard that for 30 years. We don't need any more algorithms, guys. Okay? Enough with the algorithms. It's like we've got 40 jet engines, all of different types, all of different manufacturers, and like 1 or 2 airplanes. Okay? I love the algos. They're fun. They're great. I built some. But the bottleneck has shifted, and we need to get out of that habit. So again, not a bad habit. It got us to where we are today, but a habit we need to break. We need to start realizing that we can treat the algorithms as a black box to some extent, that we can trust that they're going to work. And we need to focus on those other elements like the downstream system and the users. So lesson 4 here, and this is getting into design. Don't start an AI project until you know the decision in which it fits. I promise you that your prediction or your classification or your translation will have no value unless it drives some action that leads to some outcome. And unless you take an hour, okay? It doesn't have to be a really difficult exercise, but take an hour to talk to your users or proxy users and say, what action will you take based on this AI system, and what outcome do you hope that it will produce? 99.9% of AI projects are built like the courses we took in data science school. Somebody gives us a cleansed data set, and we focus the entire time on how to build an algorithm, whether it's a support vector machine or a gradient-boosted machine or deep learning or whatever is your favorite GAN or whatever it is, right? We're learning how to work inside the box. That's like learning how to build a new kind of jet engine when nobody's built an airplane. Sorry to keep beating on this same point, but that's what's going on. So this is a decision model. In particular, this is a picture that shows how some actions I might take. In this case, it's some investment in a marketing initiative or investment in customer experience. And on the other hand, there's this outcome, revenues, okay? And net revenues are made up of gross and total costs. And again, it's kind of boring, but if you get into it, it can be fun. And each one of these links can be supported by math or machine learning. And so what we have here with each of those light blue with the lines through them, those are places where machine learning can fit on that causal chain from actions to outcomes. This is decision intelligence. This is that other side of the future of AI. This is the layer that will sit on top of your single-link systems that help your customers get from actions to outcomes. When I started my company 10 years ago, I conducted about 100 interviews with executives and technical people worldwide. And I said, what problem should technology solve for you that it's not solving? This is what they told me. They said, help me know what actions to take and what outcomes they lead to. And I promise you, it's a complete fiction that you can figure this out by looking at a dashboard. Okay, if I show you one curve showing product demand and another curve showing price sensitivity and another curve, showing some cost of your product, it's a fiction you can put that together in your head. Okay, it's a fiction that somebody can give you 200 PowerPoint slides describing your competition in the market and all their predictions, and that you can then assemble that somehow and make a good decision. And the fact that we haven't been doing that and we don't even realize this is a whole is tremendously exciting because it means there's very low-hanging fruit. As soon as we start mapping from actions to outcomes and then inserting our little machine learning models in there, so where's my machine learning model? How does an investment in customer service intervention change customer experience as measured by some survey instrument? Machine learning can help you figure that out, right? Or standard randomized control trials. You can either do it retrospectively or prospectively. Importantly, this allows for heterogeneous kinds of tools. You can do agent-based models inside this, and there's some econometric models in here. And also importantly, there's a feedback loop there, where I'm a customer, I love my product. Because I really love it, I'm likely to recommend it to someone else, and they'll tell two friends, and they'll tell two friends, et cetera. Okay, that likelihood to recommend loop creates a winner-take-all feedback effect, and you ignore these at your peril because this is what ends up dominating markets, is these kind of feedback effects. And the fact that we're not monitoring them and managing them is kind of how we got into this mess. Climate has feedback loops. Market has feedback loops. Economics has feedback loops and nonlinear dynamics. And we've been systematically ignoring all of this. And we've been omitting how it connects to one of the most powerful technologies we've built today, which is machine learning. So this is kind of the template of that situation. If you come and get my business card, this is on the back of it. Basically, it says, during those 100 interviews, as people told me how they make decisions, it was really exciting because I heard the same mental model pattern. There's an archetype here of how people describe how they make decisions. And it's pretty simple. They say, I'm going to take some action. It'll cause something, and that'll cause another thing in this situation, in this context, and then it'll produce some outcome. And I have a new puppy. He's 6 months old. And so I've been learning formal dog training. Turns out this is dog training, right? This is context. Let's see if I can get it right. Context and cue, and then the result, right? This is operant conditioning. This is how people think. We imagine some action we're going to take in some context. My dog knows if he's sitting in the kitchen and I give him a cookie, and I say sit, and then he sits. That's his action that he takes. My context is my cue. He's going to get a cookie. Okay, so his job is to create this mental model, whether conscious or subconscious, I haven't figured that part out, right? That gets him from an action he might take within a particular context to a particular outcome. And I don't know if he's creating multi-level hyperplanes in his mental model or not, okay? But I think he might be. I see some sort of anecdotal evidence of that. So there's machine learning in there, but it's not the whole picture. Okay, so this is really important as we move into this new world. You need to understand the difference between an inside-of-the-box and an outside-of-the-box conversation. And let me speak in particular to those of you who are either not machine learning experts or are new to machine learning. Please, as you talk to your technical people, don't let them tell you how before they tell you what. Okay, and the how is very specific. What's the Gazinta? What's the Gazouta? Okay, tell me what goes into your box, and then tell me what goes out of the box, and then tell me how you know that that thing that came out of the box was good or not. Okay, and they'll usually give some answer along the lines of back testing. How do you know you can trust this? Only after you really clearly understand what goes in and what goes out. If you're curious, you can then ask them and allow them to speak about the technology inside it. But I promise you that will fill up your brain, and you won't have any cognitive room left to understand how that box fits with all these other boxes in order to drive successful solutions. So recognize you only have so much cognitive capacity. Your technical people have been trained for years and years on the math and the algorithms, and that's great, and we need to honor that. But also recognize that you don't have to learn the inside of the box. To be a great chef, Kazi Kozyrkov at Google, who's the chief decision scientist there, she likes to say, to be a great chef, I don't have to know how to build a microwave. And we have no chefs today, to mix my metaphors with airplanes, okay? We just have a whole bunch of kitchen technology sitting around, okay? So don't let somebody insist that you have to understand how their magnetron works before you can open up the thing, put in some food, and heat it up, okay? Those are different approaches to a problem. And those of us who are architects understand information hiding, separation of concerns. We can't build complex systems and at the same time know the inside of every box. We must start by understanding the interface definitions of all of those boxes and then assemble them like jigsaw puzzle pieces. Who's an architect in the room? Does that make any sense? Oh, wow. There's a lot of architects. That's cool. You can tell me if I'm wrong later or add to that because I don't think I'm wrong. Data. This is a little bit of a random order. Please don't cleanse your non-predictive data. Okay? Over the last, even just the last 2 years, I have had so many experiences where I go into a client and they say, we have a great data governance approach because we know the model is only as good as the data. And we've joined all of our tables into a master format. And we've spent $1.5 million doing this. And we have a team we hired of technical people. And we're ready to start machine learning now. What's wrong with that picture? 10% of your fields contain 90% of the predictive power. You have just cleansed a whole bunch of fields that don't need to be managed or cleansed. And I promise you, data management is the hidden stepchild of this world. It is effing hard. And so the last thing you want to do is gratuitous data cleansing of fields that aren't predictive. So to operationalize this, what I usually do is I take uncleansed data, I get it in a form that's just barely recognizable, no feature engineering, just a simple table, and I will do a baseline run. And often my baseline run, even though there might be some fields that could be cleansed better, often my baseline run, A, does not win any Kaggle competition, but B, when I do that mapping from my internal AUC or ROC measurement or false positive measurement to the external measurement, which is how much money can this company make if they use this system, often I find that even that baseline run that I spent maybe a week putting together has huge value. And I have just skipped all of that data cleansing work. Now, if I want to get better performance, and I really care about winning Kaggle competitions, which you shouldn't, what you really should care about is generating either financial value or climate value or social value or whatever your outcomes are. If you really want to do that, you can then kind of incrementally start cleansing fields. That's fine. Okay, but again, we're getting back to Agile. Each Agile sprint should eliminate as small a risk as possible. In this case, the risk is, do we think there's any pattern in this data at all? Okay, is this even something we can predict? So we'll take an example. I did a project predicting diabetes a few years back. My customers sent me 580 rows of data. And they said, can it learn from only 580 rows of data? And I think there was maybe 200 columns. I go, I don't know. If the signal's strong enough, what matters is that the signal's bigger than the noise, right? So we ran a predictor. We did a little bit of back testing, and it looked really, really good. Now, I would say that was not sufficient to deploy that thing in production, but it was enough to get further funding, to further cleanse that thing, and to get more data rows, okay? So work in small pieces. Don't do this gratuitous 2-year data cleansing project up front. Understand the model context to avoid irresponsible AI and unintended consequences. So I'll go through this pretty quickly. I think I might pay for some trees to reduce carbon. Social media shows me content about paying for trees because I search on it on Facebook, maybe. I like that content. The platform knows about me. It feeds me more information about paying for trees to reduce carbon. Great. That's fantastic. However, this is a geometric feedback loop, and so it builds on itself over time. In the short term, yeah, I'm getting some information about trees. Maybe I don't get exposed to people who say, no, actually, paying for trees is not the best way of affecting climate change. Maybe there's another way to do that. My platform's really happy. It's making money because this thing is spitting off cash in the form of ads and clicks. Isn't that great? And I'm getting more and more information about trees. So you guys know this. This is my view of the filter bubble. So before I go through this process, I might get lots of information. As I go through this process, certain topics get enhanced at the expense of other topics. Certain perspectives on topics get enhanced because that's what I like to click on, because I'm human. Okay, well, so maybe that's good as far as it goes. But now let's see what happens when I have a filter bubble. We might argue that that reduces my exposure to diverse viewpoints, which reduces my ability to separate truth from falsity. And oh my gosh, when this happens at a societal level, we lose our entire crowd-based sense-making. Hello, problem. We don't have an informed citizenry, and democracy falls off the cliff. Now, you might or might not agree with this chain of events. Okay? I'm not putting a stake in the ground and saying I'm some sort of an expert. What I'm saying is we need to draw these pictures and then have structured discussions about them. And we need to understand that we've been reasoning in short term and short time as well as short space horizons, and that we need to go to this multi-link horizon, okay? And when we start to draw these pictures, now we can start to have rational conversations. I believe that a big part of why we can't have rational conversations is we're trying to keep these pictures in our heads, and our heads are full. There's too much cognitive load there because these are very complex systems with feedback loops and massive complexities and emergent systems dynamics. How can I possibly have any sort of a conversation where I can learn something new when I'm trying really hard to keep that in my head? It's not going to happen. It's trying to balance the books without Excel, right? It's just not possible. So we need to draw these pictures. We need to start leveraging our visual smarts. And as we move forward, this is going to become kinetic. We're going to dance and move in these spaces, and we're going to be interacting with these as games. And that's going to drive our intuition even further. A couple of other pictures like this. This is the classic commons picture, which, if you remember any slide from today, I would like you to remember this one. If I pay for some money for some commons, right, and historically this was the Boston Commons, I'm paying some money, and my cows, it helps to maintain the commons. That looks negative at first because my pocketbook is a little smaller. But in the longer term, if I understand how this plays out through multiple links, the likelihood of violence is lower because I have a shared interest in that commons with my neighbors. My safety goes up, and ultimately my cows are happier. Okay? This lack of multi-link thinking is, in my opinion, and also the fact that we don't draw these pictures, the reason that we're not able to have rational debates, or a big part of the reason about these very complex issues that include massively emergent system dynamics. So do that. This is the overall pattern, right? Sometimes something that's good in the short run can lead to something bad in the long run. I call this the lobster claw pattern. I'm seeing it everywhere, okay? So when we start to do AI and we fit it into larger systems and we realize the actions that it drives and the outcomes that those achieve, we start to recognize that longer-term thinking will give us different answers than short-term thinking. So this is called decision intelligence. It's the topic of the book that came out a couple of weeks ago. I've been evangelizing this for 10 years, and it is finally making it. So it's kind of a cool story. It was on Gartner's little hype cycle thing for the first time last week. Decision intelligence, it's right there. It was identified as a top 10 technology for 2019 by Forbes. Kazi, who I'm very grateful to, she's taught like 20,000 people decision intelligence at Google. It's finally making it. And Jan LeCun, if you look at an article he wrote in the New York Times recently, there were 4 things he said humans do that AI can't do. One of them we can do, which is recognize things, and 3 other things, and they're all decision intelligence. He said causal reasoning and decision making and systems understanding, okay? And those are core to this. So there is an emerging consensus that this is the next generation of AI. So even if you don't care about all these cool social issues, if you want to be forward thinking, if you want to be kind of future-proof in your career, learn DI, buy my book. There's my little thing. So these problems aren't separate, right? This is the Millennium Project, which identifies every year the top problems faced by humanity in the next 5 years. If we want to achieve clean water, we need to understand energy, peace, health issues, the rich-poor gap. Every time we make a decision in part of this picture, it bounces around through these multi-linked causal chains to affect things in the other part of the picture. The reason we haven't solved these problems is they all share this massively complex, interdependent nature. And it's time for us to take this problem on. This is the challenge that we face, honestly, as a human race. And I made this up a couple weeks ago. I called this the Complex Holoptic Unified Multi-Link Problem, or CHUMP. It's just this big thing. I don't know if that name is good or will stick. It's probably really bad branding, but anyway, it's one problem. You can't solve it separately. 2,000 years of Western reductionist thinking have to be thrown out the window. We have to become synthesists, and we have to look at the outside of our boxes, because if we're focused on the technology on the inside of our boxes, our heads will explode. We can't do this. We can't be experts in each other's fields. We must focus on interface definitions, and any good architect knows this. So let's bring this to reality. Let's move beyond software, my architect friends, and bring some of your information hiding, separation of concerns, modular design, interface design, design patterns. Those principles are desperately needed beyond software and in the world at large. So let's see if I can get this one to work. This is number 9. Free book to the first person who can say who that lady is. Oh my God. We're going to have to give them away a different way. Okay, all right, let's try the next harder question. Why is she on this slide? How does she know everything? She's an AI. Okay, so those of you who don't know what the heck we're talking about, there's a series called The Good Place with Ted Danson, which is in its 4th season right now. And there was an episode in season 3 where Ted goes, oh my gosh, Danny gave his grandmother roses 100 years ago, and he got all these great points, and so he's going to heaven. Danny gave his grandmother, or George gave his grandmother roses this year, and those roses were produced by an international conglomerate that uses low-wage people and dumps its waste into the Potomac, la da 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 da. In a globally interconnected world, this guy giving somebody roses today, because of this chain of unintended consequences, he doesn't go to the good place. When he dies, he goes to the bad place. And Ted Danson, the whole thing about this whole series is, why isn't anybody ever making it to heaven anymore? Well, it's because they don't understand multi-link thinking. So I love this series. After 10 years of evangelism, we finally made it to Hollywood. And he's assisted by Janet. And what's relevant about her is she's an AI. But she can't solve the whole problem. It takes Ted to figure out that multi-link situation. It takes Ted, who has empathy. What's his name in the series? It's not Ted. I can't remember. Anyway, it takes him to work together with the AI to solve those really difficult problems. So she's what I call a beautiful AI interface. And these other pictures, which may or may not move, are really ugly. These are things that I've coded myself, and I think you can see I'm not a designer, but I like to experiment with different ways of visualizing things. We need designers. Are there any designers in the room? Please, come talk to me. No, come talk. Come talk. We need good designers, because these things have to be democratized. We have to get AI as ubiquitous as the personal computer is. That's a key part of this solution. All right, so let's wrap up. Finally, educate yourself, even if you like your box, even if you like your design or construction of models box. Spend a little time understanding the other boxes. Understand what assurance means for data, what assurance means for your design. Understand what it means to design for users and for the market, because you will only be successful if you work with an interdisciplinary and diverse team focusing on the decisions, actions, and outcomes that solve great problems. Thank you.